Okay, we're going to look at what happens when we have a system of equations that are not unique, so that when we throw them into our calculator, they do not give us a solution. They come up with a math error. So one type of systems of equations, excuse me, that this happens to is when we have a system of three equations that are what we call inconsistent. And that means they have no solution there is no solution to be worked out. So what you have to do is in A, basically what you have to do is determine the nature of the equations. We look at the coefficients. So if the coefficients are proportional, which means basically that the ratios are the same to each other, but not the constant, we have parallel planes. So we take each one of these equations and we compare it against the other one. And we take a look and see if the coefficients in front are basically proportional to each other. So if we take a look at equation 1 and equation 2, they're proportional because the coefficients in front are 1/2, 1/2, 1/2, -1 over -2, which is a half. So they meet that criteria of proportional. And then we look at the constants, 10 over 3, that's not proportional. So the coefficients in front are basically proportional, but the constants, these numbers here, are not proportional to each other. And that means that basically we're into the realm of inconsistent. So we should test that. We should test another pair to see if they're proportional. So we test 2 and 3. And 2 and 3 are also proportional, giving us ratios of 2 to 3, 2 to 3, -2 over -3, but the constant not. So that tells us that all three of these equations, graphically speaking, look like this, right? All three planes are parallel. So because they don't intersect at any point in any way, there can be no solution. So this is what we know is going on once we test and do this whole coefficient thing. Then we know that what situation we have. We also then have to do some algebra. So for merit, it's probably sufficient to say at this point that you have an inconsistent situation. And graphically, what this means that all three planes are parallel, so there's no solution. Algebraically, for excellence, you basically have to do this stuff in red and green, which is basically realize that I've got to take this equation 1 and I can times it by 2. And I can basically create equation 2 out of it. So if I times this by 2, I get 2x plus 2y minus 2z is equal to 220. And then I take equation 2, and then what I do is I do a process of elimination. So algebraically, I do elimination. I see if I can get rid of one of the variables. But in fact, what happens here is I don't just get rid of one variable. All the variables go away, and I'm left with 0 on one side of the equation. And then that is equal to some number. So 0 equals to 17 in this particular situation using the process of elimination. It's just a false statement. It's not true. And this leads us to realize that when we have 0 equal to some number, we have an inconsistent situation. And so we have to actually work that out. We probably should test it against another pair. So we could test sort of 1 and 3 and do the same type of thing with them by multiplying 1 by 3. And then we would get 0 equals to 22. So we have to do this algebraic thing for excellence. And then we have to make a fairly complete statement about this. There's other things that we'll have to do when we do it in context. But basically, we must state that graphically, we have a situation where all three planes are parallel to each other. And because they're parallel, they have no unique solution and are inconsistent. So no solution and are inconsistent. So you have to use this vocabulary, and you basically, if you have a non-unique situation at merit, you may have to talk graphically about what that is and take a look at the coefficients. For excellence, you will have to do some of the algebra and show 0 equaling some number and then talk about what situation you have.